A variable oil feed for a mechanical cylinder lubricator. There are various types of mechanical steam cylinder lubricators available, and not all of them have an adjustable oil feed built in. I show a way around this if you are using one of the non-adjustable oscillating cylinder type of ratchet lubricators. This clip shows a ratchet type lubricator fitted to a Stuart 5A steam engine, and this one is a bit erratic. Even though this particular lubricator has a built-in function to change the volume of oil supply, you still have to make sure that the ratchet goes round properly. Mechanical lubricators on steam engines can be problematic. It's well known that they're not always the most reliable device out there, but generally speaking, once you get them to work okay, they just carry on working. But this one's not doing its thing at all. In this clip you can see one solution. I've moved the position of the link from the eccentric a bit higher up on the arm on the lubricator. And it's still dithering about a little bit, not as bad as before, but it's still a little bit erratic. I think possibly the ratchet pawl underneath needs a stronger spring, but then if I put a stronger spring on the ratchet pawl, it's going to wear the ratchet and itself more than it would do if it didn't have such a strong spring. Oh, and by the way, the word is pawl, P-A-W-L. I've put the spelling on screen so there can be no confusion. And the position of this ratchet pawl is just to the left of the R in ratchet pawl. I decided in the end to fit the driving pin in the top hole of the lubricator drive arm, and now the movement is much more consistent. On this type of lubricator, the amount of oil that gets pumped out per revolution can be altered by the large nut on the right hand side of the lubricator. So if I find that the lubricator is delivering too much oil, I can adjust this nut to control exactly the amount of oil that I need to be delivered to the cylinder with every revolution of the pump. My Showman's engine cylinder is 3 inches in diameter, which is quite big, but it doesn't need this much oil, because the smoke box and the chimney itself and the little bit that fits in the top are absolutely covered in a mixture of steam oil and soot. And this is not good. It's not too bad on a 4.5 inch scale traction engine, but on a 5 inch gauge locomotive it soon restricts the flow up the chimney. If you watch this clip from the steam test yesterday, you will see how fast the lubricator moves when the engine's just basically ticking over. If I was driving the engine down the road, which I will be shortly when I get the passenger truck sorted out, the rotational speed of the ratchet shaft will be much faster than you see when I'm turning it by hand. I soon got into a sequence. I undid the lock nut, rotated the fitting outwards 1 turn, retightened the lock nut and turned the handle. There does come a point though when the adjustment is all over with. This is too far out, and as you can see, there's nothing much in the way of oil coming out of the end of the feed. So this is the pump at the very end of the adjustment scale. Time to slacken off the lock nut and rotate the adjuster 1 turn in. And here's the result. Some oil comes out at every turn, but not very much. A further half a turn in and the adjustment was complete. All I need to do now is dismantle the fitting that I made, thoroughly degrease it and silver solder a feed pipe onto there, and on the other end of the feed pipe will be a 1/4 by 40 threads per inch nut to connect the oil pipe to the cylinder. So to all of you out there who are either over-oiling or under-oiling, this is how you adjust the oil delivery from a Foster lubricator. This is a very common type of mechanical lubricator, but there are other types. There are lubricators with very similar internal mechanics to this one, but using a one-way clutch instead of a ratchet. There are also some types which use an eccentric on the shaft that depresses a spring-loaded pump piston. The part that I'm currently removing is a very important part of the lubricator. This is a clack valve or one-way valve. It has a stainless steel ball inside it with a spring to hold it in place. Without this, nothing will happen and steam would blow back into the lubricator. It is also very important to have a second non-return valve where the oil goes into the cylinder. As I move all the pieces out of the way, you can now see the little oscillating cylinder. Quite a nice piece of model engineering really, a model in its own right. The main shaft is threaded into the crank web. If you put it in reverse it will unscrew itself, but you can clearly see the little piston going up and down in the cylinder. The one flaw with this design is that the oil flow is non-adjustable. The spring-loaded piston type are usually internally adjustable for oil flow, but with this type you have to limit the travel of the arm. These kind of pumps are generally driven off a valve rod and sometimes with a reduction linkage. For each revolution of the crankshaft, the ratchet needs to be clicked over just by 1 notch. Any more than that and the lubricator will over-oil the cylinder. The complexity of mechanical lubricators often put people off, but they really are technically better than a displacement lubricator shown here. On the plus side, a displacement lubricator is a fit and forget device, and once you get used to how far to turn the little wheel to regulate the oil supply, they can be very reliable. But on the downside, you never really know how much oil you've got left in the lubricator. Mechanical lubricators are fine if they're working okay. On my small showman's engine there is a lubricator fitted, which is the oscillating cylinder type, and this, when I first bought the engine, was over lubricating like you wouldn't believe. The solution is simpler than you think. You just need to fit a bypass valve. Here's a dismantled oil pump showing the oscillating cylinder and the check valve on the bottom, and this clip shows an exploded view of the check valve. This type of mechanical lubricator will not function without this check valve, and it's usually a good idea to fit a second check valve where the oil enters a steam chest, because you can get a situation where condensed steam finds its way back into the oil tank. Fitting a bypass to this check valve is really simple. Here I have 2 180-degree globe valves. One's a bit small, but the second one, without the handle, screws into the check valve because the thread on it is exactly the same. One point, you may have to use a slightly longer spring. You need to check this before assembling it. With a drop of Loctite 542 on the threads of the globe valve, you simply screw it into the check valve and the job's done. The check valve still functions as a one-way valve, and the globe valve allowed me to fit a piece of pipe back into the tank. It's the same principle as a bypass valve on an axle-driven water pump, except this one is for oil, not water. It's such an obvious and simple concept, I don't know why I've never done this before, because in the past, particularly in the days when I obsessively ran steam locomotives, it would have been a quick and simple solution to the over-oiling problem, which is prevalent with this type of lubricator. Here I've removed the lid and I can now show the system in operation. The one-way ratchet just makes it so that the oscillating cylinder picks up oil on one stroke and pumps it out on the other. It's as simple as that. This is with the bypass valve almost closed, and here I'm opening it. It's very clear that most of the oil starts to run back into the tank. As can clearly be seen, the oil comes out of the pipe on the pump stroke only. And with the bypass valve open like this, the cylinder would not be receiving any oil. By closing the bypass valve altogether, the oil stops flowing out of the bypass pipe, which is fairly obvious. By watching the oil level in the tank and the amount of oil coming out of the blast pipe, I soon found out where I needed to set the bypass valve. And now the traction engine cylinder receives just the right amount of steam oil. It is a simple and uncomplicated fix. That's it for this video. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.